Welcome, everybody. In this session, Bruce is going to take you through CP, CMS commands, the XEDIT Editor, Rex. So we've spent a good deal of time already in these sessions where you've been exposed to certain commands, some CP, some CMS, and using the editor, but we've never spent the time to go in depth on those topics. So we're stepping back at this point to fill in that gap. And so take it away, Bruce.
Okay. So yeah, this is usually the very first presentation after the introduction that we do, but in the workshop with the labs, but that's because we have a system we can get people familiar with and all that. So, but that's fine. You know, we've touched on some of these things, but these are really a lot of basics that we're going to talk about it. I may just kind of repeat a few things and say, you know, this is a very basic concept, like what's a CMS file name or something like that, because it really helps, I think, as you use the system to understand some of those concepts. And obviously on this slide, we have CP and CMS, and it can be easy to get confused as to, you know, is this a CP command, a CMS command? What's it really do? What am I doing to the system? And so that's, to me, kind of part of some of those basics is to understand those differences. Now, you know, you may not grasp it right away, but it's, if I can get a little of the background in your mind, and then maybe some of the rest of the things you do in the system make a little more sense. It just seems to me that as we work with people and people ask questions, understanding some of those very basic concepts is, you know, maybe why they're confused, and that's what we try to reinforce here. But we're really going to start basic and just tell you how to log on. Now, you may know how to do that already, but you might learn some things about that screen. And then, as I say, we'll talk about CP commands, a lot about CMS, the things in CMS, and about XEDIT the editor, which, you know, if you want to change something, that's what you're going to use. So logging on. Very basic, like I said. And what do you need to know to log on? Well, what do you need to log on about any system, right? You have to have some way you authenticate yourself to the system, and then you need to have, you know, some kind of a way to authenticate that. What do you know? You know, in this case, it's a password. There is a two-factor authentication that's available with RACF. I won't get into any of that. There is that technology available, but this is the basics: user ID and a password. So you know what the user ID is. That may depend on what one you want to log on to. And you know the password that you need to know to do that. You can start on this logo screen. So I'm sure you've seen that. This part in the middle you can customize, but the parts down here in the bottom is just a helpful place on this screen where you can enter your user ID and password. They're right there. But if you don't enter it here, you can certainly enter it on the command line that you would see next, which I won't show you, but it's certainly possible. You don't have to do it on the screen, is I guess what I'm saying. So once you log on, certainly they get verified. If you have RACF, I'll just mention that RACF is what verifies your password. RACF keeps the passwords on the system, and it keeps them encrypted, that kind of stuff. You can have password phrases, which are longer than 8-character passwords. You can have up to 100-character password phrases that have blanks in them and all that kind of stuff. So that's certainly available. But basic ZVM has an 8-character password. So once that's verified, your virtual machine is created. And Richard mentioned way back in the very first presentation about everything happens under ZVM in a virtual machine. So you need a virtual machine to do anything. You know, anything you'd want to do to change the system, it's going to happen in a virtual machine. So you need to log on and have a virtual machine up and running. So you see the virtual console, we'll see the picture of that. Generally, it starts up whatever you want to have running in that virtual machine. We're going to be talking about CMS, could be Linux or something like that. So on the next page, as I said, I'll show you what this looks like as you're logging in for a CMS user. So you get this process. So in this case, I'm logging on to main. And I'll also say this is RACF is enabled, so you get this message from RACF. If RACF wasn't there, you wouldn't get this. But these first lines come from CP. It just basically tells you what version of CP you're running on. So that's that line. And well, in this line too, there is no log message data. There's something called, you know, like attention messages, log messages they're called. You can set as a system administrator on the system if you would want, but there's nothing to show. It's going to show you whether you have any spool files. So we mentioned the spool in the first session, and I'll mention more about it. But do you have any of those assigned to your user ID? In this case, he has a reader file. So it tells you to log on and when you logged on. So that's when CP is done and has created the virtual machine. This message right here, this ZVM 7.3, is actually from CMS. That's kind of the CMS welcome message or the initial message CMS puts out. It doesn't say anything about a CMS release right there, but you're running on 7.3 and when the CMS nucleus was built, if you're curious about what that time is. And down here at the bottom of the screen, it says VM read. That's the status area, if you notice that. And typically virtual machines, when they log on, when they're on CMS anyway, this is how they start out. CMS initializes and stops, and it says VM read. VM read, and we'll see all the status messages, but this area is important to keep an eye on for the status of your virtual machine. VM read says, I'm waiting for you to enter something. It's basically the virtual machine operating system has said, I want you to read data from the console. So I've done a read CCW, channel command word, to that console, and I'm waiting for input. Now, the reason it stops here is because I could override how CMS starts up if I needed to. If there's certain things you can do if you need to do that. 99% of the time, there's nothing you're going to do. And what you want to do is just let CMS start up normally. So you don't enter anything on this command line. The cursor is here on the command line. You just press the enter key on your 3270 and CMS finishes starting up. And if you're familiar with done anything with CMS, there's a thing called a profile exec, a script that runs that can set up your virtual machine. So that's what runs at that point. And you notice the status area now says running, which is the normal status of a virtual machine. And you also see this ready message. So it says ready, gives you the current time. These are actually execution times of the last command. They really aren't very meaningful, but they're still there. And now we're ready to do things in CMS. So it can be confusing when you first log in and you want to enter a command. Maybe you're following instructions. You log in and you get that VM read and you enter a command on the command line. Now, most of the time, nothing happens. It basically, when you hit enter, it initializes CMS and then it does whatever that command is. But there are a few commands, and access that we'll see later is one of them, that actually modify the startup of the virtual machine. And so then you may get confused. Why isn't my virtual machine set up like I normally expected it to be? And that would be why. So, we kind of try to emphasize when you log in and you log in for the first time and you get that VM read with this message, just press enter, don't type anything yet, and let it initialize, get the ready message, and then you're really ready to do whatever, the reason you logged on, whatever you're going to do there. So it's kind of a long explanation, but again, some of these little details kind of help you as you work with the system. So here's that status area. Here's the messages you may see. There's not too many of them and what they mean. So we've seen VM read. So a response is required. That's what I had mentioned. We see running. So your session is ready for you to enter a command, or it's still running a command. You don't really know the difference between CMS is sort of waiting for you and it says running, or if it's actually running something. That ready message that we saw that said ready with a semicolon is really the thing you're looking for that. CP read up here means CP has issued a read request and is waiting for you to enter something. So that can happen. Maybe you'll see it when you first log on. We'll talk about that. You may see CP read. And the important thing here to notice and a reason to look at that status area is maybe you enter a CMS command and it tells you it's an invalid command. Well, because the status says CP read, and so the only thing looking for a command that's going to process a command in CP read mode is a CP command. It wants a CP command. And that's kind of again, knowing the difference between CMS and CP commands, where they came from or what they're for. And so again, we'll talk about this a little bit more, but that's what that status means. These ones down here, more in holding, the display fills up with data. It does not scroll. It's just the way the 3270 works in this, the way VM defines it. So the output display area fills up. There are more lines to display, so you clear the screen. You can also press PA2. In 60 seconds, it clears itself when it says more. It basically says, I'm going to keep showing you, but I'm going to do it once a minute. And that value can be changed. That timeout value can be changed. Holding means it's not going to automatically clear the screen. And it will do this automatically if there's a priority message, maybe somebody sent you a message or some priority thing from CP. It can decide that. So it will say holding, it will just hold that forever so you can look at what's going on. Now, the neat thing is, when it says more, you can press enter and it will then change to holding. It will hold that screen, or you can press enter when it says holding and it will change back to more. And, then it would clear in 60 seconds. But probably if it says holding and you're done looking at it, you're just going to clear the screen to go on. This not accepted is a little strange. You don't see it very often, but basically it says previous input was not processed. And what can happen is whatever operating system you're running maybe is not ready to accept a command. And you see this maybe a little more running Linux than CMS. But for some odd reason, it's not ready to accept a command, meaning it hasn't really read the last one. So when you enter a command on the command line and press enter, it sends an interrupt to the operating system. He's supposed to read that data. And if he doesn't, well, CP has nothing else to do now with the new data you have entered. There's no other place to put it, right? It's already told the operating system, read this, and it hasn't done it. So CP is basically telling you, I can't accept that until the operating system reads it. So maybe you need to give the operating system an interrupt. And the way to do that is to clear that command line off so it has nothing on it and press enter. And that doesn't get unaccepted because there's nothing to send, but it does send an interrupt. Maybe that wakes up that operating system and it reads previous command. Clearing the screen can maybe work and pressing enter or something like that. You kind of have to, it just kind of depends on how you got there, but you may have to work to get out of that non-accepted state. But you don't see it very often. Good to know what it is. So here's disconnecting. So, we've logged on, we have our console connected, we're running CMS, and let's say we're done for the day, we're going to go eat lunch, we're maybe going to go help somebody else. We can, instead of basically getting rid of the virtual machine, which would be the log off command, which we'll basically see next, we can disconnect it. We can basically say, well, leave me running, leave my virtual machine running, but just disconnect my console from it. And by running, meaning it could be doing nothing, it could be just waiting for the next CMS command, or it actually could be running a command. You can let things stay running disconnected, and that's typically how Linux servers run. So it's the disconnect command, and that disassociates that virtual machine. And if you look at the status, you query all the virtual machines on the machine, it would say DSC for disconnected. Now, how do you reconnect? Well, there is no reconnect command. You don't really have to know if the virtual machine is not running at all or it's disconnected. You basically do the log on. So you log on again, and that's reconnecting. And this is where you would see typically a CP read, as I was mentioning. When it reconnects, it, as we say, drops into CP mode. It goes to CP read, and that gives you an opportunity. It does that, gives you an opportunity. What if something's running, maybe looping or something like that, and you want to stop it or you want to see what's going on with it? Well, you want to stop that virtual machine running, and it says CP read, and it's waiting for you to do something. Typically, when you're running CMS, you just want it to go back into running CMS and entering CMS commands. So you have to enter B or begin to continue it. Again, this is where you may see you reconnect. You enter a command. I enter FILELIST as a CMS command, and it says unknown command. And well, look at that status area. If it says CP read, then do that B. It's kind of like a restart the virtual machine command, B or begin, and then it typically goes back to running mode, and then you can enter your CMS commands. So that's, again, you've probably seen this if you work with a system, you've reconnected and you've seen that status display. As I said, there's a log off command. So you can, of course, get rid of the virtual machine from the system. And, when you do that interactively, you enter the log off command. And of course, when you do that, there is no more virtual machine. I mean, it exists in the directory. The system still knows about it, but it's not in memory anymore. It's not being dispatched. It's, as it says, deleted from the running system. Now, of course, if you've written things on permanent mini disks and, into permanent storage, that's still there. But yeah, it's no longer running on the system. And of course, you can log on again, that kind of stuff. So that's the basics, some real basics of getting on and off the system. So more about CP commands. So as we really kind of implied, they're used to communicate with CP. So when you want to talk to the control program of the ZVM system, that's running the show, that's what's doing everything, you use CP commands. And CP commands can certainly alter your virtual machine. I mean, that's really what they're there for, and kind of what we'll see here as we talk about basics here. But they also can alter or query the entire VM system itself, all the real devices, that kind of stuff. And, how do we know what we're doing with a CP command? I mean, besides reading what it does, but there's a privilege class associated with CP commands. What privilege do you need to run this command or to do these things in this command? And, you can generally separate the list into privileged commands and unprivileged commands. And if you're running like a Linux server, you define a Linux server, typically you don't let them do anything privileged on this system. You give them the general user class G unprivileged privilege class, as we would call it. And they can work with their virtual machine. They can alter their virtual machine all they want. It's kind of like working with their own hardware, but they can't do anything to the real system. They can't give themselves more priority. They can't get rid of somebody else. They can't attach something they're not supposed to. They're restricted to changing their own virtual machines. So that's where we worry about privileges. CP commands and actually CMS commands can be entered in any combination when you enter them on the command line, upper and lowercase. And what happens is when CP itself looks at that command on the command line and CMS, they basically say, well, I need to see if this is a command. I'm going to translate that command string to uppercase and see if it matches one of my commands. So when they're interpreted uppercase commands, you don't have to enter them that way because when you enter things on the command line, it basically takes care of it. There are times where you care whether you enter them in all uppercase or something like that if you're writing a script sometimes. But typically when you enter them in the command line, it doesn't matter. Again, you may see them documented in uppercase, but you don't have to type them in uppercase or hit the caps lock key or whatever. Now, you can always communicate directly with CP, even if there's some other operating system running, like Linux or even CMS, although CMS and CP get along really well. And this is akin, Richard showed you back when we had these rather old systems that they started on that had all the lights and buttons and dials and all that stuff on them. I mean, the heritage of this was people were used to being able to work with the machine. They could even debug things right on that console, looking at the lights, stopping it and stuff. And so they wanted to have that capability. They needed to have that capability in CP from the terminal that you're using. So you can basically, there's a couple ways to communicate directly with CP. So you can enter a CP command. Maybe you want to stop things running. Maybe you want to see what it's doing. Maybe you're debugging something you want to trace. That's why you need that stuff. One way is you can press the PA1 key. So with terminal emulators these days, you don't look at your keyboard and see a PA1 key like you did on an old 3270, but it depends on how that key is defined, or if you bring up a menu of keys, you can press that PA1 key. And that basically sends an interrupt to CP and says, okay, I want to talk to CP. Then what you'll see, the status will change to CP read. That status down in the lower left corner would say CP read, because now CP has said, you want to talk to me? Okay, now tell me a command, and I will do it. The other thing you see, and you've probably seen this more often, is you can put this pound sign or hash sign CP on the very start of the command line where you enter a command on the command line. And basically CP is the one that, controls your terminal. So he sees the command first. He's the one that looks at it first and says, okay, what do I see a pound CP, or is this for me? And if he does, he basically processes that command, and it never gets sent to the operating system that's running in the virtual machine. It's communicated directly with CP. So, you've seen instructions that say enter pound CP disconnect to disconnect. Well, that basically bypasses any operating system like Linux, so you don't have to go through the Linux command processing. It says, I want to tell CP this is what I want to do. I want to disconnect my console from my virtual machine, and that's what happens. So that's another way to always directly communicate with CP. This character can actually be changed. If there's a reason that you need to enter a pound sign, a hash sign on a command. But that's the default, is the hash or pound sign. So here's my thing about privilege classes or user classes, as I was starting to talk about. And so the way IBM has set this up with privilege classes, they divide them into 8 groups. Each represents a privilege class. Each one is a letter, a single letter. There's actually 32 privilege classes because they're user-defined ones, but A through G is the ones we worry about. So that's the type of user that you have when the system accepts commands. How do you get a privilege class assigned to your user? That's something in the user directory. So whoever creates that directory entry would do that. The thing I want to emphasize here, and I'm going to even put it in bold, is some CP commands, you'll see a command, but the output that you see may change based on your privilege class. And really the times you really see that, it has to do with devices on the system. Because a virtual machine has virtual devices and the real machine, the real LPAR, has real devices, right? And if you want to work with virtual or real devices, some commands may look and say, well, if you're privileged, I'm going to show you real device information. And if you're not privileged, I'm going to show you virtual device information. Or there may just be more output, more details that you get if you're not privileged, or privileged versus not privileged. So again, it's something to understand as you work with CP commands. Maybe you're running on a privileged machine, and so maybe you're seeing output about the real machine, the real system versus your virtual machine. So that's something to remember. These are the IBM defined classes that they set up on the system. And this is the sort of the original meanings of them all, right? Class A is the system operator who controls the VM system. And of course, the system operator user ID has Class A privileges, but other IDs, and typically administration IDs, have Class A privilege also. They can do similar commands. So you might say the highest class, but we'll have a little caveat down here. Class B is system resources, so basically real devices, real resources, that kind of stuff on the system. So when you query and look at devices. The Class C, the system programmer class, could be argued has more privilege, is the highest privilege of the system for some reasons. There are some Class C commands that really can alter the security of the system and things like that. Anyway, it's basically a lot of system-wide parameters. Class D is associated with spooling. So we're back to, in the old days, card punches and card readers and printers, but it's also, now we use the spool files. We use the spooled area on the DASD so they can control those files. And if you had a real reader, printer, and punch, that's what they did, but you don't really see that anymore. Class E is a lesser version of Class C. There's a few things. Class F you don't see. That was really for, an IBM rep that was looking at things about the system. You don't really see much associated with that. And here's my general user class. So you can control your virtual machine, and if you don't have any of these other privileges assigned to your user ID, because you can have multiple privileges, you don't just stuck with one, then you can't really do anything to the real system. There are some what it's called Class Any commands, like to log onto the system. It's a Class Any command. You have to be able to log in no matter who you are, and you really have no privilege at that point. There's not too many of those, but those do exist. Now, typically, a user ID that is a system administrator, like I say, may have any or all of these privilege classes, but they also have Class G, because you really need Class G to run CMS at all. I think even to run Linux, you really need to have those privileges as Class G. So typically you have Class G plus some or one or more of these other ones, depending on what the role you are on the system. So the most basic CP command is the query command. It's just a, it's a query. It looks at information. It doesn't change anything. As you can see, it says the status of the virtual machine, the system, real and virtual devices, all kinds of things on the system. And this is, like I said, one that may vary based on your privilege class. And there are a whole lot of these. They add them, for various reasons, because typically when you change things or whatever, you want to be able to see what the current state of things are. The documentation associated with ZVM is really pretty good. There's quite a few of them. So I mentioned here that there's a CP command and utility reference. So that's where you find out about CP commands. So here's some real common, real simple, like what is my user ID? What am I logged onto? Or what DASD devices do I have? Now this is one, if you're Class G only, it's going to show your virtual DASD. If you have Class B privilege, it's going to show you real DASD. So that's one that'll change. What are my PF keys set for? What is in my reader queue? What time is it? What's the time zone? That kind of stuff. And names shows the names of the other virtual machines. It's a query who's logged on. Is what that query names does. So again, very simple set of things. Define and set change configuration and settings. So define may typically make something new, and set may change something that exists. And these also, if you have privileges, then they change the entire ZVM system. So we use define and set for those as well. We don't have a separate set of commands. It just has to do with the subcommands, as they're called on there. Now, when you change things, right, you're making a dynamic change to your virtual machine or the system, right? You're just saying, I'm going to make this change now. And of course, they remain in effect as long as you're logged on, or you change them again, or they remain in effect for the system as long as the system is running until it is shut down. But the next time you log on, or the next time the system is brought up, those settings are not remembered. You'd have to do them again. So Richard already mentioned a lot about system config when we talked about system config, that there are a lot of settings in there. And so generally, if you want to make a change to the configuration of the system, you may enter a set command or a define command to make that change to the real system. But you also want to make that same change in the system configuration file. And most of the settings go in there. There are a few places that they don't. But you want to make that same change so that next time you bring your system up, you still have that same setting set up. So that's kind of the warning here that, these are dynamic changes and they don't survive a shutdown of the system. So defining a virtual disk and storage, a virtual fixed block 512, defining a virtual NIC that I may attach to a vSwitch, coupled to a vSwitch. Defining storage, of course, VM uses the old term of storage where we're talking about memory here, not disk storage. So define storage, I may want to change the virtual memory size of my virtual machine, But I can also dynamically add nowadays, add memory to the real VM system. I think it's a set storage actually command, not defined, but it does use that storage subcommand. I can set a program function key in my virtual machines that only affects me. I can set how I see dates. I can, if I have privileges, I can set it for the system. And this is certainly a privileged command. Set share sets priorities. So that's one thing that you wouldn't be able to change in your own virtual machine. A privileged user can. All right, so that's a lot about what the system looks like and maybe even some system-wide things. Now we're really going to talk more about in your virtual machine and kind of as we worry about the CMS environment. So the storage, of course, in a virtual machine that disk storage we talk about is disks, DASD. And Richard mentioned on the first thing that we have mini disks. We can divide up a real disk, DASD, whatever it is, into smaller chunks and call them mini disks. Of course, mini disks can be used by Linux, but they can certainly be used by CMS. We don't typically need the huge amounts of disk space in CMS that just store some scripts and things that we need to, have an entire Linux file system in there. So we may have a lot of mini disks in a CMS environment. And so, like I said, I can have my own mini disks with my own data on them, but maybe I want to use a system mini disk or I want to share a mini disk with somebody else that has some files on it. So that's what the link command is for. So I can make a mini disk associated, owned, if you will, by another virtual machine available to my virtual machine. So it's really a pretty simple syntax. I say link, and I tell it the mini disk I want to link to. And a mini disk is owned by a user ID in the directory. It has a virtual device number. So everything has to have a device number in there. So, maybe we talk about mate 190 if you've seen that. So, that's a user ID and a virtual address. In my virtual machine, I need to define it as a virtual device number, one that's not used by, I haven't used previously. So that's what the VDEV2 is. It could be the same. I could make these two the same number. That's kind of nice to remember where things are, but it could be different, and sometimes it is. And then there's this mode, link mode. We'll show those on the next page, a little more about them. It's basically, do I get this read write or read only? And there could be a password associated with that mini disk. I may need to know the password to be able to link to it. If RACF is active, then I don't worry about this part of it because RACF is deciding if I'm allowed to do that or not. It basically has a permission in RACF, and so you wouldn't put a password in there. But if RACF is not active and there is a password, that you would need to know that password. Or maybe there is no password and anybody can link to it, like read only. Little demonstration here. So I have two users, Mike N and Mary R, and they have mini disks in their directory entries. This is just showing the virtual address of them, none of the other data. But, there's 3 disks for each of them on wherever they are on the real disk of the system. We don't really care. But anyway, Mary R wants to read-only access on Mike N's 304 mini disk. And there is a password. So she enters on her console link to Mike N's 304 as 900, right? So it's this disk. She wants it as 900 in read-only mode, and that's that password. So once she enters that command, now she has a new mini disk in essence. It's not hers, but it's in her virtual configuration at disk 900, and it's really this 304 disk. So when she reads, whatever's on this disk, she's reading from this disk. It doesn't matter if Mike N is logged onto the system or not, because this disk is defined in the directory, so it can be, read basically. So she's made a temporary change to her virtual machine configuration, right? She has this mini disk and she can read it. When she logs off, she will no longer have that link to that mini disk anymore because she didn't make a change unless she made some change to her setup of her virtual machine to make that permanent, but she can make that temporary change. So this is really pretty frequent, especially when we talk about CMS, that we link to disks, maybe we read things, and maybe we then get rid of them later, that kind of stuff. So that's the basic link command. You'll see later when you see the link, there's also a link statement in the directory that does the same thing. It doesn't have the keywords to and as. These are optional. Kind of sounds better, but you don't have to put them in there, but you can if you want. So there are actually 12 link modes, that mode field I showed you. And I'm not going to go through all 12 of them because we don't really use most of them. I just basically give you the ones that are the most used here. And the default is a read-only link. A read-only link is established. So you get that disk if you're permitted to, and or you know the password. Read-only, you can read from it, you can't change it. We'll talk about why there are 2 R's here in a second. So there's M and MR. So here's where the 2 letters come in. So M is actually by definition called a multiple link write request, which sounds a little nasty. But the important point is that the definition here, a write link is established unless another user has an existing write link to the disk. So this is a safe way to link a disk because CMS does not support multiple users changing a disk that is linked read-write at the same time. There's no way to coordinate the writes. So, you can only have really one virtual machine updating a CMS disk. So M is safe because you get a write link unless another user has a write link. If I need to update this disk and I need a write link, then I ask for an M type mode, and it either works or it fails, which is nice because I can say, oh, it failed, so I wait till later or whatever I need to do. MR is, you see this quite a lot. This is, again, a multiple link write. A write link is established unless the user has an existing write link. So what the double letters are is I'm going to try this one first. And if it doesn't work, I'm going to then fall back, if you will, to this type of link, a read-only link. So then it says, if that fails, a read-only link is established. So this is, again, good for CMS because I'm going to ask for a read-write link, but I'm okay with just reading the disk if I can't get a read-write link. So I get a read-only link. So that's what the double R means. I'm going to ask for a read-only link. There's actually a provision there. Does anybody else have a read-only link? I may fail, but that's why it's, oh, well, I'm going to go for a read-only link anyway, even if other people are reading the disk. So the dangerous one is MW in a CMS context, especially a multiple write link. And notice it says a write link is established. There's no ifs, ands, or buts. I'm going to give you a read-write link if you're allowed, and it's up to you or whatever you're running in your virtual machine, whether that's okay or maybe that's dangerous. If it's a CMS disk and multiple people have a read-write link, then you're in trouble. That disk is probably going to be corrupted and will have to be reformatted and reestablished or restored from a backup disk. So my caution typically on MW is if instructions are telling you to use MW, then use it. If you're following instructions and they say use it, then use it. Otherwise, stay away from it. Use M or MR, right, to get read-write access to other disks. If some other virtual machine has a write link and you need to write on that disk, then you need to either find out who owns that virtual machine, get it off the system, get rid of the link, something, before you can alter that disk. And there are also stable and exclusive links. This SR, stable read-only, is used by the system when CP accesses the system config. Well, I say you'll see later, but we've actually already seen it. It's kind of nice that nobody else can update that disk once it's accessed. So other link modes, there's W link modes. You'll see write, which you would think would be for asking for a write link. And it certainly works, but a write link will fail if any other user has a read-only link. It's just part of the description. So you can look at the documentation for link and it'll tell you all about all of those link modes if you're curious about more of them. So let's get to CMS here, the conversational monitor system. So it's part of the system. That's that interactive environment we've kind of been talking about. Probably the biggest thing that really, that you do with operating systems is you work with files. So CMS has a file system. But it's also, you can run, of course, programs on it, tools, that kind of stuff. Certainly we use CMS to service the system, monitor the system, do all kinds of things. That's a lot of the, run the TCP/IP stack that I talk about. They all run under CMS. So CMS does a lot of stuff. How do you start up CMS? Well, to start up a virtual machine, an operating system in the virtual machine is the IPL command, initial program load. So typically you say IPL CMS. Well, what you really IPL normally are devices. So here's IPL 190. That's the CMS system disk, which is virtual address 190. But we have these things in CMS, Richard mentioned it briefly, called name same systems and disconnected save segments are the other part of that. So we can actually put out there something called a name save system called CMS, which contains basically the same CMS nucleus, CMS kernel. What happens with name save systems is actually part of the memory of that is shared by multiple users read-only. And, in today's terabyte memory sizes and gigabytes, this is just a drop in the bucket of a few pages that you're saving. But when we only had, 16 meg on a system or less, it really made a big difference that we saved those memory pages across users. So we still have name save systems in there. So typically you just type IPL CMS. We also now have a Z architecture CMS, so a 64-bit CMS, and I'll put an asterisk on that, meaning it will run in a 64-bit environment, but CMS is still a 31-bit addressing, 32-bit data operating system. It really runs and only uses up to 2 gigabytes of storage of memory. But we do have a ZCMS if we want to run some program that wants to make use of Z architecture facilities. We can do that, and some things do that already, like PerfKit. So we can IPL ZCMS and we start ZCMS. There's nothing to shut down CMS. Basically, if you're back at a ready prompt, nothing's happening. CMS is basically idle and files are closed and all that kind of stuff. So, of course, you can kill it in the middle of something and you can have those consequences depending on what it's doing. But typically, when you're back at a ready prompt, you just log off or you IPL something else. So, again, that kind of makes it a pretty simple operating system from what we see these days. So CMS commands, a lot of them let you work with the CMS file system. So files in the CMS file system, and you can change, of course, the setup of CMS in your virtual machine. They can also be entered in any combination of upper and lowercase, as I mentioned. And I didn't mention CP commands, but most CMS and CP commands have abbreviations defined and can be abbreviated. So they did this early on, so they didn't have to type so much. They were typing on typewriters early on. So that was kind of nice. And so these tend to be documented. When you see documents, like I say, the commands are really uppercase commands, but they kind of show you the whole command with the shortest abbreviation this way. So AC is an access, Q is a query, S is a set, DEF is defined, copy, COPY is copy file, all that kind of stuff. So when you see things documented that way, that's what it means. And also that's why you see sometimes when things are documented, you may just somebody, entering Q space DASD, or you may see it as query DASD. They're both valid because they can all be abbreviated, or most of them can be abbreviated. There's a help facility. I didn't really mention it before now, but it applies to CP as well, and really all of the subsystems of ZDM, but it's implemented under CMS. It's a CMS command. So there's this online help, and that's really good to find out, what is the CP command I'm looking for? What's the syntax? What does it do? CMS commands, the whole deal. So there's the CMS help command. And if you see a message, you can enter help for a message. That's pretty handy. You give it the message number because messages typically have numbers. Help for a command, help for a component, like help CMS, help XEDIT, help DIRLIST. And help tasks is kind of the more, I don't really know I don't know to enter help DIRLIST. I want to see what kind of things I can do. And tasks is actually the default. So if you just enter help, it does a help tasks, and you get this, basically you would see this menu here, and there's more here. There's more tasks here than I'm showing, and so you would use the typical PF8 to go forward, PF7 to go backward. The highlighted things are places you can put your cursor, so you can move your cursor to one of these, or you do a mouse click kind of thing, and press enter, and then you will go to the menu for that component. So you can see CP, CMS, the directory now, DIRLIST, and on it goes. XEDIT's down there somewhere, pipelines. Yeah, there's lots of tasks menus that are help. So it's really very extensive. They basically use the documentation. You might say the same source materials to create the documentation to create the help screen. So it really reflects from a command reference point of view, really what's in the documentation. Sometimes there's a little bit more in the documentation, but most of the time, most of it's all there in the help facility. So it's really the first thing I always go to when I'm looking for something. I go, help, whatever, read that before I go looking at PDF files and documents. So the CMS file system, certainly just about any operating system wants to have a file system in place to store data. That's usually the purpose of it. So, of course, files in any operating system have a way to identify files. What is a file identifier or a file ID? In CMS, it's 3 fields: file name, file type, file mode. So we're going to see these as we talk about CMS files. And so if I say file name, I'm typically talking about just that part of the file identifier. Now in Linux or Windows or whatever, you typically see name dot extension, right? Of course, Linux, Unix can really have anything you want, but you saw the name dot extension. So in some ways, the file name and the file type is that way of specifying. It's kind of the name and the extension, or we call it the type here, kind of what type of files, what's the name of the file. The mode is associated with where the file is, so we'll talk about that. Now, there's no dot in between file names and file types. There's spaces, so that's why I say 3 fields. It's really, it looks like 3 words, basically. So, it's file name, space, file type, space, file mode is a complete description of a file in CMS, a file identifier. So some CMS commands assume what type of file, the file type that they work with, so they may just want a file name, right? So it really depends on the command, whether you specify the entire name type mode, or do you enter just the name, or is it optional to enter the file type and the file mode, that kind of stuff. It really depends on the command. But typically when we're working with files, we have to refer to these 3 fields. So the file name and the file type are 1 to 8 characters. So we're pretty limited on names from modern standards. But, the heritage was we didn't have long names and we had less memory to store them in. So that's where we started out. And you'll notice it's certainly the alphabetic characters, the numbers, a bunch of special symbols. So that's kind of nice. But you also see lowercase a through z, a through z. And they're actually legal in file names. I said when you enter a command, it gets translated uppercase. So yeah, it's really hard to create a file with a lowercase file name, but it is possible. There are some interfaces to do that. And maybe it's even harder to refer to them. So you don't see those very often, but they are legal in file names. Typically, you'll just see the uppercase, the numbers, and like I say, these special symbols, whatever you need. So there's some help there. The file mode, so that last part is just 2 parts, a file mode letter, a single letter, so it's single characters, I guess what I want to say, and a file mode number, a single number. So it's pretty short. So the letter is an alphabetical A through Z only, no lowercase, no numbers, just 26 of them assigned to the mini disk where you want the files to reside. They're accessed. We'll see that in basically the next chart, talking about the access command. So we'll talk about that. And the file mode number, you may not always see. It's a number from 0 to 6, so there's even fewer of those. And really what they are is they have special meanings to CMS. Some of them do. Like file mode 6 means update in place, and file mode 3 means erase after reading. So it's a temporary file. So you write a file with some data. When you read it, it basically gets automatically erased. So the default is 1, and that's what you see. 2 is also a very common one that you see, file mode 1 and file mode 2. And you usually don't worry about it. When a file gets created, it's going to put a file mode, typically 1 on there. That's perfectly fine with what you're using it for. And you probably don't want to change it because there are some of those special ones. And if you don't know what they are really for, then you really don't want to, you sort of don't want to go there. You don't want a file to disappear that you're thinking is going to stay around, or maybe it just doesn't work right. So the default number is 1, and you typically don't type them in when you're specifying file identifiers, but you'll see them. That's why I'm kind of telling you that they're there. So here's my access command. So it identifies a mini disk to CMS. In Linux terms, it's like mounting a file system, right, to Linux. So that makes that file system available to Linux. Access makes the files on a mini disk available to CMS. And so we associate that file mode letter. So I said, that's what the file mode letter means. It means what mini disk it's on. So you have a mini disk that's already in your virtual machine. Maybe it was there, you linked it. I already showed you the link command. Now you access it. You can just say AC if you want. The virtual address and a file mode. So I'm going to access 999 is Z. And if there was nothing accessed at Z before, then that's what it does. If there was, it may replace it. But that's fine. Now the files on that disk I can reference directly by their file name, their file type, and file mode Z. So an example may help. 3 mini disks. They are formatted for CMS. They have CMS files on them. You can see them here, what's on there. 200, 400, and 900. So now I'm going to access these things at different file modes. I'm going to enter 3 different commands. So Baker, Dog, and Z. So you now see these have changed because there is a file mode associated with them. Before the files were there, but I really couldn't use them in CMS because there was no file mode associated. So now if I want to read a file named My Data, I can read My Data B to read that one specifically, or My Data D to read this one specifically, or My Data Z to read that one specifically. These are all different files, and I have to specify that file mode to know which one I'm reading. If I want to read the file name Still More without specifying a file mode, it can kind of look for it. It'll find this one because it won't find it on the earlier one. We'll talk about that too. So that's what the access command does. So, if I want to read the files or work with the files, I have to access that disk first. So here's this thing's search order. As you might imagine, alphabetic file modes implies an order. So it creates a search order, A through Z, alphabetic, and that's how CMS, if it needs to, will search for commands or files. So if you specify a fully qualified file identifier, test files Z, there's no searching needed. I know exactly what I'm looking for. If it doesn't exist, it's going to tell you it doesn't exist. But if I use an asterisk as a wildcard, so maybe I can leave it off in some commands. I can not specify it at all. then it finds the quote first one. So it goes down through the search order, whatever's disks are accessed, and looks for this file, as I was kind of showing you on the previous page, and it'll find the first one, basically. CMS commands, a lot of them are files on disks. They're either scripts or they're binary objects that are run. And so when it searches for commands, it uses the CMS search order. So the thing is, when you run a command, you really can't tell it which one to run. The important point is, if you want to put an executable file on your A disk, an exec, a module is the binary thing, you can actually override a CMS command with the same name. Whether you did that intentionally or unintentionally, it can cause some confusion. Maybe you want to override a CMS command and do something different, but maybe you don't. So you can't force the system to necessarily run the commands off the system disk that, as it should be. It could use something that it finds earlier in the search order. That's why the search order is important. So CMS assumes some devices. So when CMS was first developed way back when, and it was called the Cambridge Monitor System, we think basically the machine that they had these devices at these addresses. That's just how the system was set up. It would have been a 360 and all that. So they had a 191 disk. Well, they had a string of DASD at 190 to 19 Fox probably. And so they started using the 190 disk as the CMS system disk. That's what everybody shared, that disk read-only. Everybody had it accessed at file mode S for system, and that's where all of the executable commands are. And then they had a disk at 191, which they used for private space. So now that became file mode A, it's automatically accessed as file mode A, the very first of the search order. If you're searching for a file, that's where it's going to find it first if it exists. So that's a private read-write disk. So that is typically there. And then the other ones we have as part of the common part of the ones that are shared by everybody, 19D or 19dog is where the help files are. So when you type help, the help command basically accesses that disk at some free file mode, unused file mode, and shows you those files. You don't really need to worry about it, but you'll see it there. And then 19E, or the system disk extension, as it's called, that's why the E in the address is accessed at file mode Y, so very far down in the search order. It's called the system disk extension because it's considered to be part of this CMS system disk, but it basically has extra things on it. Common parts of other products, extensions of CMS. It could have some local system things on there, whatever. There's a lot of things that can go on the Y disk. It tends to be kind of a bit of a catch-all for stuff. So you'll see these addresses if you query virtual DASD in your virtual machine, and that's what they're for. And you'll see them accessed at A, S, and Y when you query that part, what CMS has accessed. And that's what they're for. Now, the unit record devices, the spooling devices, there are commands that work with those in CMS, and they have to be at these virtual addresses. So just to complete the picture of what default devices we have a card reader at Charlie, a card punch at Dog, and a printer at Easy, 00 Easy. What we use the spool for these days to exchange files between people. We don't really, of course, punch cards or print things. So there's a few ways, more than one way actually, to find out what disks you have accessed. So I talked about the access command. So they give you some information in some different forms. So there's query disk and query accessed. Query disk is the one we had originally, but now we also have query accessed. So the thing is, this is showing you what's accessed. You may have more mini disks in your virtual machine definition than you have accessed. Maybe you linked things and haven't accessed them, or you got rid of them, or they just were part of your virtual machine definition and nothing ever accessed them. So you can use a CP command because that's part of your virtual machine configuration. We use a CP command to find out our configuration of our virtual machine. Query virtual DASD. So what are my virtual disks that I have? That lists basically all of the mini disks that you have. So it lists both accessed and unaccessed mini disks. It doesn't really know, CP doesn't know what you've accessed in CMS, right? This is the split between CP and CMS, but it'll show everything that exists, and you have to kind of figure out between the two which has been accessed and which hasn't. So that's some of that difference there. And I just actually had someone the other day say, he said, I didn't have this disk in my virtual machine. And I said, because he did a query disk, and he said, I don't see it. I said, well, it's there. You just didn't access it yet. So here we are with the query disk and query accessed output. So you'll notice that it shows me virtual device addresses. So this is probably on a maintenance user ID, what file modes they're accessed at, right? A, B, C, D, E. So, I've gone down the list here. Whether they're read-only or read-write, can I write to them or can I just read them? So like these shared disks that are part of the CMS system, I can just read them. These are all my personal ones. This is a maintenance user ID, so he's got a lot more than maybe some other people, but I can read and write to them. And I get some information on how much they're used and how full they are and that kind of stuff. That's kind of handy to have. Query access is a little simpler. It just shows me first the file mode. It does show you the virtual device, and it shows you that disk label. Many disks have a label too. It's not just on real disks. And this is going to be a little handy because you can kind of see maybe who owns the disk. That's typically, you have 6 characters in a label, so it's a little short, but now you may guess that this is owned by Maint and it's the 190 disk. So that's kind of nice to know. When you talk about shared file system, that's why this says directory. This may show a shared file system directory. That's another nice thing about query access. So how do you find out what's on a mini disk? You use the LISTFILE command. There's actually another way, the FILELIST command. So the LISTFILE command displays a list of file names, shows the file name, file type, and file mode as you see things. The syntax is just LISTFILE, and I do it this way with a capital L because the shortest form of it, the abbreviation, is just L. File name, file type, file mode. And then you give options to a CMS command with the open parenthesis. So in Linux, you use a dash and a letter or something like that. In CMS, that's how we do options. We do an open parenthesis. You can optionally do a closed parenthesis, but that's how options are specified. And in this specification, you can use wildcards. You can use asterisks, % to represent set of characters or a single character. If you just type L or list file name, file type, these searching things default to asterisks. So it searches all file names and all file types, and the file mode defaults to A. So if you just type L, you're going to see what's on your A disk. If you want to see something on another disk, you have to specify asterisk, space, and then that letter. So the FILELIST command displays a menu of files. It actually shows you a full screen type display. I have examples of both of these. That abbreviation is FILEL, right? And the reason it's not F or FI is because those were already taken, unfortunately. So it's a little bit longer. But it's the same syntax as the LISTFILE command. So this syntax here. So file name, file type, and then options. The nice thing is you can scroll through the files, you can sort them, you can execute commands against them. It's really handy to use. It's much easier than doing a list file and just remembering what they are. So here's a list file of everything on my B disk, everything accessed at file mode B. So I did list file asterisk space B, and notice I get a list of files. And there's a lot of files on the disk. I don't remember how many. And so this says more, meaning there's more to show me. If I wait, it would clear the screen for me in 60 seconds, that kind of stuff. And here's where you see these file mode numbers that I talked about. Notice we really haven't specified them, but this is a file mode number 2, and this is a 1. Basically, 1 and 2 mean the same thing in this case. So that's what you're seeing. But if I do a file list, I get this screen, okay? And this actually uses XEDIT Editor. You'll see that down here to make this screen, but we don't really care about that. But what it's showing me in the, the green part here, this unprotected part, is the files on the disk. Again, they're file mode and with a letter, and it shows me more data about that. LISTFILE can show this too if you give it options. But what format it is, how big it is, when it was last updated. That's what this is, a last update date. And you can change this time format, things like that. By default, it sorts it by the newest file first, the most recently updated, and sorts down by there. So that's why you see a different file at the top, if you will, at the top of the list. But FILELIST is very handy. I can enter commands here. I can use the PF keys, like here's the XEDIT. I can XEDIT this file by pressing PF11, but I can also sort by file type, sort by the date, which is the default. I can sort by the biggest file. Let's say my disk is very full. I want to see what's taking up all the space, that kind of stuff. So FILELIST is very handy, and that's really what you'd be using to do that kind of stuff. So the opposite of access is release. We got to have something like that. So it releases a disk that we had accessed before. So like I have a 194, it has files, they're accessed as B, right? I can actually work with those files. But if I type release B, release in the file mode, still have the files on the disk, they still exist, but you notice that B is gone. I can no longer work with them directly, like edit them or whatever in CMS because I've released the disk. But the disk is still there, right? I could type in access 194 is B. I could work with those files again. There's another option on the release command, open paren detach. So what this does, detach is a CP command. And that's how you get rid of a virtual address. You detach it from your virtual machine. So what this does is does a release B, the CMS part of it. CMS releases this disk, and then it does a detach 194. This detach takes a virtual address. And now I no longer have this disk available to me at all. It's no longer part of my virtual machine configuration. I assume that files and the disks still exist. Depends on who owns the disk and how it was created. But more than likely, they still exist. I can link it again, probably, and then access it again. But if I release and detach it, I no longer see it in my virtual machine configuration. And really, this detach option is just a convenience, so you don't have to do two commands. You don't have to say release B, then detach 194. CMS just does that for you, but it's handy to know about. So here's my VMLINK command. I wanted to do this after I've talked about accessing and releasing. This is just really more of a handy or a shortcut kind of command. It easily links and accesses a mini disk with one command. And, I showed you with link, you had to pick a device address in your virtual machine, a virtual address to use. When you do an access, you have to pick a file mode that's probably not used. Well, what VMLINK does, it looks for, gee, what have you used, what is not used, and just picks an unused device address and an unused file mode. So that's pretty handy. You don't have to go find out what you used already. So the syntax is very simple. It's just VMLINK, a user ID, and a virtual device. I don't need to tell it, what device I want to use to link it with and all that kind of stuff. I can. There are options to do that, but I don't normally have to because it finds the unused thing. So the other thing on the link command and even the VMLINK command, the user ID can be asterisk, and that doesn't mean link to every user. That means to link to myself. So sometimes an asterisk in CP commands means myself in CMS commands. I want to link to my own, and then I have to give it an address. So I can enter VMLINK asterisk 191. Let's say I did a release A detach. Oops. Maybe I want to get my 191 disk back. I could actually do this VMLINK to my own 191 disk. Now, these options, I'd mentioned options start with a parentheses. If you want to read-write link to something, you just put the option write, or just even a W. That even shows you the abbreviation. If I need a password, I can tell it a password. And I even enter FILELIST, and I can go directly into FILELIST after linking the disk. So there's some neat options in VMLINK. It's pretty handy to use. I even told somebody yesterday who's done a lot of VM stuff, I said, he was typing link and then he was typing accesses. I said, why haven't you learned to use VMLINK yet? And he says, I'm trying to learn. It's kind of funny. It's been there quite a while, probably 20 years or more, but people are sometimes set in doing what they're doing. Just to mention the help facility, Help CMS VMLINK would tell you all about VMLINK. It's got a lot of options, but you can certainly use it in this simple form to do things. All right, I don't want to get too long in the tooth here. I think I'm explaining things a little more than I normally would, but I don't mind the details, but we may get through some of this other part a little more quickly. Copying files, pretty basic. We always need to do that in any operating system. And it's just the COPYFILE command, or just copy, and I just give it the full source, file name, file type, file mode, and the target. Where am I copying it to? File name, file type, file mode. So it can be kind of a long command, test file A to new text A. But I'm going to make a new copy of a file, or I can copy it and put it on a different file mode so it goes on a different disk. And it has a couple shortcuts. I can use an equal sign to say, well, so this is the file name, file type, file mode, file name. It has the same file type of the source file. So test file A becomes new file A. File type does not change. And I can even copy with wildcards. So all files with the name of test, any file type on A, I want the same file name, the same file type on the C disk. That would only copy one file in this case, but you can copy a bunch of files that way. Rename is very similar syntax to COPYFILE because we have to give it the old and the new. But of course, I'm not moving the data anywhere. I'm just changing the name. So data file A to temp stuff A. And I can still use those equal signs too if I want, but I'm only typically working with one file or so. Yes, you need to have the old file mode and the new file mode, and they basically have to be the same, or you could use an equal sign because it's going to be the same. You can't move a file to a different file mode using rename. It'll basically give you an error, but it does require that in the syntax. And of course, I can erase a file, give it the full specification of the file, and it will, of course, erase it. So if I erase data file A, I get rid of data file A. If I erase data asterisk A, so it does accept some wildcards, I get rid of data file A and data file 2A because they all have the file name data. Or if I want to erase all files with a file type of test. It would erase those two files. And a somewhat more dangerous one, erase data file on every disk that I have accessed. Now, it says data file on any other access disk. It must be accessed read-write. Of course, I must have read-write access to that disk, or I can't erase a file on there. You may think, can I enter erase asterisk, asterisk, asterisk? And you can't. It's actually, or you can't even enter erase asterisk, asterisk A. That is syntactically not allowed. I think it's more of a fail-safe kind of thing. There's a way to do a really quick erase of an entire disk using the access command, actually. So there's some limits on this, but you can erase a bunch of files easily if you need to. So shared file system, mentioned just a little about this because you do see it on the system. It's an alternative to mini disks. So the data itself is on mini disks, but a server basically manages that. And so then we have a tree structure of directories where we can basically organize the data. But we put CMS files on there. So we have the same CMS commands, file naming rules. We have the search order that all applies to SFS. There are additional commands because we are working with something new with directories and what's called a file pool. And you allocate space from a file pool. So this is, again, a little more like what you see with file systems in Linux or something like that, where there's a kind of a big chunk of free space, and you can say, well, you're allowed to use this with a quota, and you're allowed to use this, and you're allowed to use this much of it. But if you're not using the space, no space is taken up. A mini disk, if they give you 10 cylinders from a real disk, those are your 10 cylinders, and nobody else is going to use it. And whether you put one file on there that takes up 6 bytes of space, the whole rest of that disk is unusable by anybody else. But in a file pool, that free space is usable by everybody else. You can basically over-allocate the space. So there are user IDs, service virtual machines, as we would call them, on the system that come with the system. They start with VMserv, so VMserv S, P, U, and R. They own these file pools. They come with the system, and this is kind of what they are. The one we probably see the most is we work with the service file pool once we install a system, but you may do stuff with VMsys in there too. A little bit of a picture. The file pool server under this user ID owns a bunch of mini disks. That's where the data is. It's still got to be on a mini disk. It's got to be on a DASD at some point. But our users, the people that have space allocated on here, basically interact with the file pool server directly, and the file pool server does all the reading and writing to the disks. That's how that works. So they use this IUCB. I mentioned this with TCP/IP. They use that to communicate with the file pool server, and then they work with their files. So you get a new command, like one called DIRLIST, show me the directories that I have assigned to me that I've created in the file pool. So this file pool is set as the default file pool. That's why it shows up with just a DIRLIST command. But you can see I have a bunch of directories. This is when you install ZVM and you put all the service in SFS, this is what you'll actually see. So CMS service, CP service, stuff like that. So that's what it looks like. This is called a file space. I'm on mate 730. These are the subdirectories, one subdirectory, 2. I think you can have 8 levels, that kind of stuff. And there are CMS files in every one of these, or can be CMS files in every one of these levels. If I move the cursor in the command line, and let's say I go down to this, I think I go down to the sample one to show my example, and I press PF11, it'll show me the files in that directory without having to do any access commands. You use the access command, but it does that automatically. So shows me what directory I'm looking at. Here are the files in there. You notice they just look exactly like I showed you with FILELIST before. It actually tells me, though, that it has temporarily accessed that directory as file mode Z. It was unused. It picked it. And when I PF3 to quit out of FILELIST, it's going to release that file mode. So access and released are used just with SFS directories, just like they were with mini disks. And you see the files in there. Mentioned spool files a few times. You mentioned readers and things, just to tell you a little about, because we do use them in CMS and do work with them in CMS. The system spool holds reader, printer, punch, and console files. And of course, when you create files, you print them or punch them, or lines end up on a console. When you read them in a reader. That's what the reader's for. So that's the files that we see. Spool files are identified by whoever owns them and a spool file number. They don't have file names and file types or anything like that. They have a number. And so each user can have 10,000 spool files, 1 to 999, or well, not even 10,000, one less than 10,000. And I said there's these types, punch, print, console. That depends on what created them. And then there are these queues. Now, the one we would mostly worry about is our reader queue, because that's how we read them. But when we had real punches and real printers, we still have the queues, but that's how files were printed on the printer and punched on the punch, is we would put them in those queues. So they can hold files, but they typically just kind of sit there until you put them and move them to a reader so you could read them. So you still see these, and we saw that when we logged in. It said I had one reader file and no print and no punch. So we know about those queues. And then there's something called the system queue, which has all the spool files. So if you're privileged and you want to look at everything, you can do that. And there's a transfer command to move things. So like I said, if you had something in your punch queue, you want to actually look at it, you have to transfer it to your reader. Or you can send it, transfer it to another user, and they can read it. So there's things you do with spool files. Typically, we use CMS commands that automatically manipulate that, as we'll see here. And we don't really worry too much about the files themselves. We may query to see what we have. So CP commands to work with it: spool, close, change, transfer, purge. Purge, you can imagine what that one does, gets rid of things. And I can query, what's my reader, what's in my print, what's in my punch. But these are CMS commands that we would typically use. If I want to send a file to someone else, I may use send file, send a CMS file to another user. If I want to print or punch, basically, and maybe send that file to somebody else, I can use those. I get rid of a file with discard, and I can view the files in my reader with RDRLIST. So that looks a lot like FILELIST, same kind of thing, but it shows me spool files, not CMS files. And that's where I can use peek. Let me look at something, let me read it in, let me put it on my A disk or another disk, or get rid of it. That's where discard comes along. So those are pretty handy. RDRLIST looks like this, and you'll notice it's different than CMS files because it shows where it came from, what class of file it is. A lot of times you'll see console files because we can, as we call it, say spool the console. Basically everything that appears on the console to go into a spool file. So maybe I end up with them in my reader. There's a name associated with it, more of a tag. And by default, if I enter receive without telling it what name to put it, that's the name it's going to attempt to write the file to. So that's kind of handy. But they can have no name associated with them, and then I have to give it a name if I want to read it in. So that's PF9 is receive automatically. PF11 is peek. Just let me look at it. I don't want to bring it into my virtual machine. I don't want to put it on my disk. I want to leave it in the reader, but I can look at what's in there. And that's pretty handy just to kind of look through. Maybe I want to look at these consoles they were all from the single day, but at certain times to see what I was doing at that time. So I can just peek at them. So that's a quick thing about RDRLIST. And it's good to know because, again, you work with DIRMate. DIRMate may send you files through the spool, and you're going to want to read them in or look at them. The editor, our final concept here. We have a full screen editor. So we use, the whole 3270 screen. We can move around and edit files. Pretty good stuff. Of course, we would assume we'd have a full screen editor these days, but XEDIT was a kind of a revolution when it came along because we didn't have nearly as nice of an editor before that. So there's subcommands, commands to search, or I want to go to the 1000th line of a file or something like that. We can do those kind of things, of course, to save our work and stuff like that. There's a profile, or basically a setup file that can use to alter the defaults. And you can write your own scripts. They're called user-written macros, so you can do some pretty powerful things. And there's help, of course. So help XEDIT menu to see what the editor commands are. That's pretty good. The default screen looks a little bit like this, just to show you what these areas are. There's a command line down here. So that's where you can enter an XEDIT subcommand. You can actually enter CMS commands, CP commands too. They're sort of passed along. This area with the equal signs is called the prefix area. We'll see what we do with that. We can work with the lines using prefix commands, as they're called. This thing is called the scale. So this just shows you, it's not part of the file. It just shows you, it says column 1, this is column 10, this is column 70, this is column, A lot of things originally, especially like assembler and stuff, were very column dependent on how you edited things. So like assembler, the statement had to start in column 10 and the comment had to start in column 40 or whatever. We cared what columns we were on. So this is part of the default setup, but typically people turn that off and don't show it on their screen. So that's fine. This just shows you what you're editing, and this shows you maybe how big it is, what changes you've made, how many alterations, that kind of stuff. So that's all good to know. And this screen is through the profile and stuff, you can change quite a lot on here of where things are. So you can use the PF keys on your terminal, PF8 for forward, PF7 backward, pretty standard stuff. You can use commands, so you can go up 100 lines, down whatever. You can go to the top of the file, the bottom of the file. You can go to a particular line number by putting a colon in front of it. And then, of course, you can change lines, There are commands to change lines, line mode commands. And usually you use those to make a bunch of changes through the whole file. I want to change, every instance of, A to B. Let's say, I don't know, I don't have a good example in mind, but you can make those changes. And you can, of course, find things. So the locate command, and you put a delimited string. The funny thing about the locate command, it's a command that has no abbreviation, because the default, if you just put a /, a thing to search for things, it searches. It searches by default. So it's kind of nice, but the command is actually locate. And of course, you want to save your work. So save to a file and keep editing, or save to the file and exit. That's the file command. Or you can quit. You can exit without saving the file. So, if you didn't want to make a change, or you accidentally made a change, you can get out of the editing environment. So prefix commands, those are the things that go in those equal sign area, and we'll show an example of that. So kind of go through the common ones. They're generally single letter commands. They're pretty short. So the / says make this line the current line, and it's a little hard to maybe show this with the examples, but sometimes you kind of move a little bit through the file, and the / can be handy. And there's certain commands that it works on the current line, so you need to know what the current line is. Try to mention that as we go through the examples. But there's insert and add. So there's a synonym for that one. You can do I's or A's. And you can also put a number after these things. So I want to insert 5 lines. So all of these prefix commands can take a number after them. And then I can copy, move, and delete lines, as you would expect. So, copy makes copies, move just moves. I can duplicate lines. That's what the double quote means. So I can say I want this same line, I want 2 of them. Or I can put the number after them, so I can say I want 6 of them, right? So I can do that with the numbers to do blocks of lines, like with copy or move or whatever. But I can also use a double version like CCMM to do a block of lines. I want to say, okay, I want to move 5 lines, then I want to put them somewhere else. So that's what I'm talking about here, this block of lines. And I'll show you an example. But when I want to copy move, right, I need to tell it where I'm copying or moving it to. So prefix commands P or F for so preceding or following. So place the lines preceding this one, or place the lines following this one. So a 3270 doesn't have the concept of knowing where the cursor is, kind of like you're used to on Linux and stuff. You might say, oh, insert it here. Well, that's where my cursor is. That's where I want to do it. It doesn't really have that concept. So that's why we have this prefix area to do this kind of thing. So let's say I want to copy these 2 lines as a block. So I put a double C, copy, right? What it says, line 1 and line 2. And I put it following this line. So I put an F there. So that's where I could put the F, the P, wherever I need to put it. Then when I press the Enter key to execute that command, notice I now have those 2 lines as a block copied to these 2 lines there. That concept of the current line that I mentioned, just to kind of finish that off, it's usually, it's a little hard to see with the, I did this with a white background, not a black background, but the black means it's highlighted. It's usually the highlighted line. By default, it's in the middle of the screen. It can be moved to the top of the screen. And so if you put a /, like if I put a / here on this line and pressed enter, then this line would become in this position on the screen, right? And all that thing would move up. So that's that concept of the current line. And sometimes it's useful for commands, but sometimes it's useful just to reposition what you're viewing in the file. I do that quite a lot, just to say, well, I want to see on the screen this block of the file itself. And so I want this particular line to be kind of at the top of my screen. And so I'll use that / to do that. So here's where we can change the editing environment completely. I mean, there's a whole lot of changes that can be made, but you can kind of stick to the simple things. But I can set what the program function keys do. So the default actions, I can get rid of that scale, or I can move it. I can control how mixed case and uppercase and things like that are treated by XEDIT. And it has to do more with when I enter lines, are they automatically put in uppercase, or when I search for things, how do I search for? Do I search mixed case, is required, or does it kind of ignore case? And then when I'm searching, do I wrap around the bottom of the file? Like if I start a search near the end of the file, does it wrap around and start at the top and keep searching, or does it end at the end of the file? So you can create a file called profile XEDIT, and that can change the default settings. And it's basically just a script, right? And when you get the system for the first time, like the Mate 730, Mate 720 ID has one on there. Not all of the IDs on their A disk have a profile XEDIT, and there's certainly not one for the system. So if you don't have one, you get that default setup where you see the scale in the middle of the screen and that kind of stuff. But if you do some editing on like mate, then you may see something different. And so when I entered the XEDIT environment to XEDIT my profile XEDIT, guess what happened? It ran the profile XEDIT. So you can actually kind of see the results of that running in this screenshot. There is a way to start XEDIT without running the profile. Let's say you made an error. So what you see is like set num on. So what that means is instead of equal signs in the prefix area, there are numbers, the line numbers basically, with zeros in there. So that's what that did. Case mixed ignore. So I want to enter things in mixed case, but I want to ignore case when searching. I set some PF keys, and then there's set scale off, right? Now the scale is gone. I've set the current line on line 3. So that's that highlighted line I was talking about. So you notice the third line of the screen, 1, 2, 3. That's the current line. That's the highlighted line. And by default, it starts at the top of the file. And top of file isn't part of your file. It's just telling you that's where that is. And I've set the command line on the bottom. So instead of being one up, and it said XEDIT one file before, now it's on the very bottom. I could say set command line top, and it would actually be right here if that line is available. So yeah, there's a lot of different things you can set. You can find out what your friends are using, that kind of stuff. You can manipulate things as you go through. So that's the profile XEDIT. This is actually, because it has Rex style comments at the top, it's actually a Rex exec. We didn't really talk about Rex, but you can do more sophisticated things with it. But this is a very simple version of it.
Thanks for watching. If you enjoyed this video, don't forget to like and subscribe to see more videos like this one. Have a suggestion for another video topic? Feel free to leave a comment below.